Welcome. Welcome to this session of pharmaceutical analysis. Today we are going to discuss about the different technique of the analysis. In the previous session we were talking about the types of titrations. These titrations which are based on measurements, so then they are differentiated into the volumetric and the gravimetric analysis or titrations. When the volume of the titrant is required to complete the reaction, it is known as volumetric titration, and when the weight of the titrant is required to complete the reaction, is known as gravimetric titration. If you see the nature of the titrant, then these titration they are of two types, aqueous and non-aqueous. The titration in which the sample solution using the water as a titrant, then that means include water as a solvent, that is known as the aqueous titration. And while other than the water we use as a solvent, it is known as non-aqueous titration, like dimethyl formamide. The third one, which is based on the principle of titration, and we have seen the acid-base titration, which is a titration of the acidic or basic compound by the consequent acid or base, just like the titration of the HCl with the sodium hydroxide, and the titration of, for example, potassium hydroxide with hydrochloric acid. Then we have seen the two types of the titration, which is the acidimetry and the alkalimetry. The acidimetry titration is a titration of the free base or salt of weak acid with a strong acid. Free base or salt of weak acid with a strong acid, it is known as acidimetry. In alkalimetry, titration of free acid or salt of weak base with a strong base, it is known as the alkalimetry. We have seen the application part, which is used for the determination of acid content in wine or some fruit juice, determination of acid content in milk, total acid number, edible, inedible oils and fats, like and boric acid, determination of boric acid in the nuclear power stations, and some of other like active ingredient in drugs or raw materials. The next is very important, is the oxidation and reduction titration. These reactions they are mainly based upon the oxidation and reduction reaction by using an oxidizing or reducing agent. Just like an example, the permanganate titration. This titration is known as permagnometry. These reactions are commonly known as the redox reaction because there is a reduction occur and the oxidation occur simultaneously. By name itself, it indicates that the change of the oxidation state or transfer of the electron of the reactant by use of an oxidizing or reducing agent. Now the first thing is, for example, if we are using an oxidizing agent, which are like iodine, potassium dichromate, potassium permanganate solution, cerium 4 salt, hydrogen peroxide, these are the example of oxidizing agent which oxidized. The oxidizing agent, they oxidize other but reduce themselves. Always remember, the oxidizing agent, they oxidize others but reduce themselves. Oxidizing agent like iodine, potassium dichromate, potassium permanganate, hydrogen peroxide, cerium 4 salt, and some example like oxidized chlorines. Some reducing agent. These reducing agent, they reduce others but oxidize themselves, like sodium thiosulfate, oxalic acid, and hydrogen peroxide. Hydrogen peroxide behaves both, right, like an oxidizing agent plus as well as reducing agent. So these are the agents which help during the oxidation reduction titrations. There are a number of types of the oxidation redox titration. We will discuss when we will study them in detail. Now the application part just about this oxidation titration is because it is used for the determination of chemical oxygen demand, which is abbreviated as COD of water. Determination of oxidation capacity of water by using the permanganate, and also determination of free and total sulfate in water, wines, alcohols, dried fruit, etc. And this oxidation reduction titration is also used for the determination of vitamin C. Now the next titration is the complexometric titration. Now what is this complexometric titration? These titration are mainly based upon the complex reaction by using a complexing agent such as the titrants. Complexing agent and the titrant, they react and make a complexing compound. Just like example is EDTA titration, ethylene diamine tetraacetic acid. These reactions, they are carried out by a complex formation by combining the ions, by using complexating agent. Complexating agent is EDTA, ethylene diamine tetraacetic acid. Now one very important thing, that when these reactions which we are talking about in the titrations, when in these reactions, such like in this case, the complex is formed, then how we determine that whether the complex has been formed or not? So the point at which it is made the complex, it is known as the end point. And for detecting the end point, we use an indicator. Just like in the complexometric titration, we use metal ion indicators, which shows that the complex has been formed. This indicates that now the reaction has been completed, and the amount of the metal ion indicator is used has completely covered the complex, and now it has been the reaction has been completed. Now we will calculate further for whatever we are our objective is. Now what is the application part? See, this is one of the example in which the cyanide plus silver, which makes a silver and cyanide complex. Now the application part is of the complexometric titration. It is used for the hardness of water in terms of the calcium and magnesium. Now also the determination of copper, nickel, lead, zinc in the plating bath, and also the determination of calcium and magnesium. The next is precipitation titration. What is these titration? These titration are mainly based upon the precipitate form. So when the precipitate form by using the precipitating agent, just like the silver chloride. So there are sometimes also known as the silver chloride titration, these precipitation titration. Why? Because these reactions, they are carried out by the formation of a precipitate by combining the ions by using the precipitating agent like the silver chloride. Now the application part of these precipitating agent or titration is the determination of chloride in water. Determination of chloride in many number of finished food like the cooked meat, preserves, etc. And determination of chloride in dairy products, and determination of silver in various alloys, for example like the jewelries, and also the titration of halides. The next is non-aqueous titration. If you see the non-aqueous titration, as mainly based upon the titration by using the non-aqueous titrate, just like perchloric acid, sodium methoxide, dimethyl formamide. So these are the compounds which are used instead of the water when We will discuss. But when our analyte is not soluble in water, when it is not compatible with the water or the aqueous phase, so then we will use non-aqueous solvent. And these non-aqueous solvents like the perchloric acid, sodium methoxide or dimethyl formamide. So then we use these non-aqueous titrations. So we are discussing all these things in a very brief. One by one we will discuss them in detail in the coming sessions. So the next point is the condition which is required for the titrimetric analysis. This is very important because whatever the reaction we are proposing or what we are taking, the reaction must be very simple, which can be easily expressed by a simple chemical equation. Just like the titration of sodium hydroxide with hydrochloric acid, which can be expressed by a very simple equation, just like you can see that NaOH plus HCl gives the NaCl and H2O. So always the reaction must be very simple. The second is the titration should be relatively very fast. It should not be slow, it should be very fast. The end point, by using the indicator, right? The end point should be detected by physical or chemical change. So these are two types of the indications. One is by using the physical indicators or by using the chemical indicators. So we can also choose both of them, physical indicators and chemical indicators. We will discuss what are these. For example, the color depth change, precipitate formation, complex formation. So these are the types of the conditions which are required for the titrimetric analysis. The reaction should be simple and the titration should be relatively fast, and the end point should be detected by the physical or the chemical change. These are the conditions: simple, fast, and end point always must be detected by physical or chemical. If they are not detected by physical or chemical change, then it will not be titrated. It will not be successful titration and we will not analyze anything. So these are the basic conditions which are required for the titrimetric analysis.